Hello everybody and welcome to my new SQL Server Quickie. I hope you have enjoyed the last Quickie where I have talked about thread pool starvation in SQL Server. This SQL Server Quickie was recorded in a completely new high quality format, and this format is now the foundation of all subsequent SQL Server Quickies based on your positive feedback. In this SQL Server Quickie today, I want to talk about the public toilet of SQL Server, DempDB. Today I want to concentrate about one specific problem that you might encounter within your DempDB configuration, Latch Contention. Imagine you have a very high concurrent workload, and this workload always creates a lot of different temp tables in DempDB. Depending on your physical layout of DempDB, you can hit very easily Latch Contention. So let's now move on to the flip chart to describe what Latch Contention is and how we can finally resolve it with some configuration changes within DempDB. As you might know, a lot of different things are happening within SQL Server when you're creating a new table. SQL Server has to find 3 pages within the data file where the newly created table will be allocated and stored. For that purpose, SQL Server uses specialized pages, the GUM page, SGUM and BFS page. I've already talked about the GUM and SGUM page in the second SQL Server Quickie, where I have talked about extents in SQL Server. For normal tables, that's not a big problem because you only create new tables during the deployment of your database schema. But imagine, for example, you have a stored procedure, and inside that stored procedure you are creating a temp table, and the stored procedure is executed by hundreds of different parallel concurrent users. In this case, the same approach is taken. SQL Server uses the GUM, SGUM and BFS page to determine where the temp table is allocated and stored within the data file of DempDB. But when you are reading and writing to pages in memory in the buffer pool, SQL Server has also to synchronize the access among all parallel executing threads. Otherwise you would have phantoms like 30 reads or lost updates, but just happening in memory. For these synchronization tasks, SQL Server is using so-called latches. A latch is a lightweight synchronization object. You can compare a latch to a lock, but a latch is only acquired when you read and when you write to pages in memory. On the other hand, the lifetime of a lock is determined by your transaction isolation level, which you can control directly. Latches can't be controlled directly. There's nothing like a latch isolation level within SQL Server. There are several kinds of different latches within SQL Server. The most important ones are a shared latch, update latch and exclusive latch. The shared latch is always acquired when we are reading pages from memory from our buffer pool, and the update and exclusive latch is always acquired when we are writing pages in the buffer pool. And both latches are incompatible to each other, which means you can't read and concurrently write a page within memory within your buffer pool, and you can't write and concurrently read that page. So you have a blocking scenario inside your buffer pool, inside your memory. Imagine now we have a workload, and that workload creates temp tables. So we have here a temp table that we are creating, and as we have said, we have to read and change the GUM, SGUM, GUM page and BFS page. Means when we are reading those pages, SQL Server acquires shared latches. When we are changing those pages, SQL Server acquires exclusive latches. This means when we have here a lot of different threads which are executing that specific statement, that specific stored procedure. The first one, for example, acquires the shared lock. Another one which acquires an exclusive latch has just 2 weight. So it's a locking and blocking scenario, but inside the buffer pool, inside the main memory of SQL Server. What we can do here to overcome that so-called latch contention is to add additional files to your DempDB. Imagine we're adding here an additional file, means also we have an additional SGUM, GUM and PFS page. Means SQL Server accesses the first file, the second time second file, third time the first file, fourth time the second file. It's just a round robin allocation that SQL Server is using here, which means the first thread can acquire its shared lock, second thread can also acquire its shared or exclusive latch, because we are reading and changing a different set of SGUM and GUM and PFS pages inside the buffer pool, because we have additional data files for DempDB, and within each data file we have a different set of GUM, SGUM and PFS pages, which means when you are hitting latch contention within DempDB, you can overcome that specific problem by adding additional data files to your DempDB configuration. So by now we are switching over to SQL Server Management Studio, and I will show you how we can reproduce latch contention within DempDB, how we can identify it, and finally how we can resolve it by adding additional data files to DempDB. The first step of this demo, we are creating a new database. Within that database, we create a simple stored procedure. As you can see from the definition of that stored procedure, in the first step I'm creating just a simple temp table, and afterwards I'm creating a unique clustered index on it. Finally, we are just inserting 10 tummy records into that temp table, so it's really a simple, straightforward stored procedure. Nothing special with it. In the next step, we create another stored procedure which just executes the first one 100 times in a loop. Finally, we can execute now that stored procedure, and as you can see, everything works as expected. So we are now able to deploy that change into production. Not really, because we haven't yet done any stress testing. Testing with just one concurrent user is the half of the story and doesn't tell you if you have any concurrency issues with your code. So what we are doing in the next step is to stress test that stored procedure with 100 parallel users. I'm using here the tool ostress.exe that is part of the RML utilities that you can download by free from Microsoft. As you can see from the highlighted command, I'm just executing this stored procedure with 100 parallel users. So let's copy this command over to the command prompt and execute it. When we now look into SystemOS waiting tasks, you can see a huge amount of queries which are currently waiting. They are waiting for the wait type page latch update on the BFS page, as you can see in the column resource description. This is now the synchronous access to these specialized pages in memory that is currently serialized by SQL Server through the acquiring of latches. You can also see from the wait statistics through SystemOS wait stats that we have a lot of waits which have occurred because of the latching mechanism within SQL Server. As you can see from the command prompt, our workload took a little less than 1 minute for execution. This is now also a very simple baseline against which we can compare a next test run that we execute when we have made configuration changes inside DempDB. So what I'm doing now in the next step is the clearing of the wait statistics so that we get a clean set of data after we have made changes in our configuration. This is not really recommended for a production environment because you are losing all your historically wait statistics data. After the wait statistics are cleared, I'm configuring the data file of DempDB with a better initial size. The default size is 8 megabytes, which means that SQL Server will always reset the size to that one as soon as you're restarting SQL Server. But trust me, you will never ever have a DempDB with just 8 megabytes of size when you are running a real serious workload on your SQL Server. In the next step, I'm now adding an additional data file to my DempDB database. You also have to make sure that that file has the same size as the other one, in my case 512 megabyte, so that the allocation mechanism can run very efficiently. With two data files, SQL Server is now able to parallelize the creation of the DempDB data in a much better way, which will improve the concurrency and the throughput of our workload. So what we are doing in the next step is to rerun the same workload. You should always do that same approach. Make your change, rerun the workload, measure your new gathered performance data and compare it against your baseline. Don't try to make too much changes in one single step, because then you are not able to measure clearly which changes were good ones and which changes were the bad ones. When we now rerun our workload and we look into system OS waiting tasks, you can see that we have fewer tasks which are waiting of latch contention. So SQL Server is now able to run the workload much faster. As you can also see from the output of the command prompt, we are now about 10 seconds faster than earlier. When you look into the wait statistics, you can also see that we have produced less waits on latch contention than in the earlier test run that we have executed. So that's also the truth that we have made a good configuration change for our DempDB. The question is now how many data files you should have for DempDB. When you are hitting latch contention in DempDB, you definitely need more than one file. A raw suggestion is about 1/2 to 1/4 of data files, as you have cores assigned to SQL Server. But to be very sure, you have to test it with your specific workload. Just do the same approach as we have seen here. Add additional data files to DempDB and measure if the throughput is better, the same, or even worse. Easy, isn't it? As you have seen in this SQL Server Quickie, it's very easy to hit latch contention when your workload is dealing with DempDB. Latch contention means that you have a concurrent access to pages which are latched by SQL Server and a blocking occurs inside your buffer pool. In the context of DempDB, this means we are accessing our PFS, GUM and SGUM page by different queries concurrently. Overcoming latch contention within DempDB is also very easy. You just have to add additional files, because with additional data files you get an additional set of PFS, GUM and SGUM pages, which then SQL Server can latch concurrently, which will also improve the throughput of your workload. I hope that you have enjoyed this SQL Server Quickie about latch contention inside DempDB, and I'm looking forward to see you in the next one. Now all our SQL Server programs are just gone.